So, trotz des nostalgischen Themas sind ja doch ein paar junge Gesichter hier. Also es geht um C64, da werden wir alle wieder jung. Ja. Oh, right. So, excuse me, this is because talk in English, so all the non-German speaking persons in here can stay and they will still profit. So, Peter Fuhrmann will tell us something about real nostalgia, hacking the C64. So, Peter.
Yeah. Okay, is the microphone on? Is it working? Okay. Okay, first I'd like to tell you a little bit about myself. I'm Peter. I'm an electrical engineering student. I study in Gelsenkirchen, that's in the Ruhrgebiet here in Germany. And my interests are in electronics mostly, and in microcontrollers, programmable logic, FPGAs also, and of course retro computing. I especially like the C64. I'm also a member of Das Labor in Bochum. I'll tell you a little bit about that group. This is our hackerspace. Yeah, these pictures are two impressions. We built all that blinking hardware stuff you saw down in the lab if you were there. It's like we're the group at the end of the room if you go through. Yeah, and it's a cool room and cool people, so if you ever visit Bochum, come and check it out. Okay, what this all is about? It's about the C64 DTV. Now, who of you guys knows the C64 DTV already? Hands up, please. Okay, that's most of you. Okay, so it might be that I don't tell you anything new at all this evening, but okay, let me just do the introduction I wanted to do. It's like, we all know this computer. Maybe for most of us it was the first computer we had or something like that, and yeah, I still like it very much because of the old games and the music on it, and yeah, it's like nostalgia feeling when you still use it. And you know, there are still people who do new demos on it and still develop new software for it. You can even browse the web with it, I heard, so it's like really cool community, and it's always fun to hang around with those guys. Some of them are pretty cool. So yeah, C64 is always like nice for a party or something like that. And of course, we all like to play the old games sometimes on the C64. And that's also what the guys thought who built the C64 DTV. Now, the DTV looks like this when you buy it. Although the packaging is quite nice, it's really a pain to open it. You know, if you ever open one, you know what I'm talking about. The C64 DTV is a handheld TV game with 30 games. It's a clone of the real C64 in an ASIC. It's like an ASIC chip inside the unit. Yeah, it's interesting to note that it's not an emulator, but it's a real C64 in hardware. You know, it's like a hardware reproduction of the original unit. It was designed by Jerry Ellsworth. She's from USA. And yeah, the unit is manufactured in China, like all the cheap rubbish stuff you can buy somewhere. It was introduced in Europe in 2005. So my talk is really somehow a little late on the topic because it already exists 2 years. But therefore, I can tell you lots of stuff about it. Yeah, it costs about 25 euros. It got cheaper the last days because it's presumably out of production by now, but you can still get it. I tell you later where. I tell you some specs about it. It's got a 6502-ish CPU. That's like the CPU that also the C64 has, or every other computer from that era. It runs on 1 megahertz clock speed normally, like the C64. The ASIC itself actually runs on 32 megahertz. That's because it also makes the video and stuff like that. It's got 2 MB of RAM, 2 MB of flash, 320 times 200 dots of resolution, with 256 colors. Okay, this is what I'm going to tell you about today. First, I'm going to show some hardware modifications that are possible. Then I'm going to show you how to transfer data onto the DTV. I'll tell you something about the structure of the system and the difference to the real c64. I'll show you how to flash the flash, add new games, show some development tools and some nice case mods, and maybe if we still got time in the end, we'll watch a demo. So let's go on. Okay. Maybe I first show you what the unit does when you get it. Well, although you all know, don't you? No, okay. Okay, so I'll show you. Wait a moment. This is okay. All right. Well, this is what it doesn't do, but okay, this is the way it comes up when you first buy it. You know, my unit is really already modified, so I had to trick it into thinking it's not modified. So it first shows all this advertising rubbish from the people who made it. And yeah, it's really painful. You must watch this once every time you turn it on. After you play the game, you can reset it, then it doesn't come again. But you must first enter one game, and then it's going to be okay. Okay, now we come to the part that always comes. Yeah, this is a little keyboard demon that's typing this in, so you don't need to type it. It's just okay, and like the idea is you select a game, like maybe, which one was it? Impossible Mission maybe. The other one is Mission Impossible. You sometimes mix them up. You don't get what you want. And you already noticed.
Stay a while. Stay forever.
Okay, this was quite like you can play a couple of c64 games. Well, the problem is they don't all rock. Like this one really rocks. We all played Mission Impossible maybe in the old times, but okay, most of the games suck. That's one of the problems of the unit. But okay, so this is what it's like when you bought it. Now let me show you another thing, because the developers of this unit are really cool. And I missed it. When this screen comes and you wiggle the stick left and right, it loads $ instead of star. And then you get a directory with some extras. And you can even, on the unmodified unit, select basic prompt. Loads it up for you. Okay, run the basic prompt. There we are. Now, how do we type? We haven't got a keyboard. Well, they were kind of creative. You press the fire button, and then you can like say 10. Don't really need that space, but whatever. That's for print on the c64. You know, it's actually fully functional. You can type in everything you could on the c64. Wait, where's okay? Oh, oops. Yeah, well, whatever. It's like a little painful to type on this, but actually you really can enter basic programs this way and run them, and it's like cool feature from the cool developers of this thing. Okay, so let's look at some of the problems the unit has got. Because at first we don't have got a real keyboard. It only runs on batteries. You know, you might have noticed I've got a power supply at it right now, but that's already modded. I just didn't want to bring any batteries to show you. And the colors aren't right. I'll explain that in a minute. And it doesn't run off favorite games or demos, only the 30 games that are on it. Okay. So we need to modify the hardware. We need a keyboard connector, a disk drive connector maybe, a joystick connector. We'll need one of the latter two, because you need to get data on the unit somehow, right? And you can either do it by disk drive or by joystick. I'll tell later how it goes by joystick. Nice to have would be a power supply connector, of course, and the color fixed, like to fix the colors that are broken. And maybe if you want to reflash it and you've got an SST flash, you need a fix for that one also. I'll tell you about that one later. We'll first look at the other mods. Okay, this is what the PCB of the DTV looks like when you open it up. Let me show you with the mouse. Up here, we've got the power supply. It's like a one transistor regulator. I'll tell you some more about that in a moment. This is where everything happens. It's the DTV ASIC. It's like in such a blob, but yeah, some blob ICs are really nice. I didn't like them a time ago, but hey, sometimes they're cool. This is like the oscillator. This is the RAM. This is the flash. In this case, it's not an SST. This is an Atmo flash. Down here, we've got the digital to analog converter for the graphics output. And down here, we've got the digital to analog converter for the sound output. That's a R2R ladder converter. I'll tell you about that in a moment. Okay, and here's the connector to the front panels, the one with the switch here in the back and the LED. Okay. Yeah, right. I wanted to tell you, to connect a keyboard, it's really easy because we've got some nice nifty solder joints. It's this keyboard data and keyboard clock solder joints that are here. You just need to connect an ordinary PS2 keyboard to them and give it 5 volts and it will operate fine on the unit. I've got one here, I'll show you in a moment. And here are the connectors for the disk drive. It's like you only need this attention signal, this clock signal, and this data signal. The real term for the floppy connector is an IEC connector, but no one really knows that term if he's not really in the C64 scene, so whatever. Okay, go to the next slide. Okay, about the power supply. The DTV's power supply is strange in 2 ways. The switch on the back here doesn't switch plus battery, but it switches ground instead. That might work out a little strange if you got a grounded power supply to power it and the grounded monitor you connect it to, maybe it doesn't turn off when you turn it off or something like that. And the LED is a part of the discrete 3.3 volts regulator. That is in fact interesting because it means if you leave the LED out, the voltage will just go up and damage your ASIC and you have to buy a new DTV. So don't take the LED out when you mod it. So like to build a nice power supply for the DTV, you have 2 options. Yeah, a question? Hello? No, nothing? Okay. You have 2 options. You can either use a regulated 5 volt supply instead of the battery. Maybe use a 7805 or something. Or the second option, then you just keep the normal discrete regulator. The second option is to replace the regulator, the regulator with a real integrated 3.3 volts regulator. That really works better, as it turns out. Okay, let me tell you something about the color fix. This is what the palette of the DTV looks like when you buy it. You see there are really 256 colors, but you haven't got the right luminances as it seems, because the most are very dark and the others are very bright, and like there are 4 blocks visible here, so it can't be right. It should look something like this. That's a picture from an NTSC DTV. Now the problem is the video DAC, that's for digital to analog converter. It is this unit on the board. I already showed you before, but this one is in more detail. It's only these resistors up here. This is the schematic. These are 2 R2R ladders. They are called R2R ladders because you've got like Rs, that's like 330 ohms, and 2R. That's 680 ohms. It's roughly the double of the 330. So yeah, you use these resistors to convert these digital signals that come in here. These are the 4 digital bits to 1 video out bit. I'm not going to explain in detail how it works. Just here, if you look at it, the most significant bit connects through 1 resistor to the output terminal, and the less significant it gets, the more resistors are in the row, so you can imagine they have a less impact on the complete signal that goes out. Now, when you are an electric engineer, you might notice the values are reversed. You're supposed to use 2R here and 1R there, but they did it exactly the other way around. Same goes for the chroma DAC, but that isn't as bad as it turns out. But for the Luma ADC, it's really bad. So how can we fix it? Okay, what's wrong with this? Okay, there's the next slide. Yeah, once we figured it out, it was really easy. This is a fix suggested by Mikkel Holm Olsen. He's from, I don't really know from where he is right now, from Sweden, I think. Is he from Sweden? Not sure. He just said, hey, let's just solder another resistor in parallel and it will be a real easy fix. All the fixes like were rip the one resistors out, put the other ones in, and that was like really painful to solder, but this one is really easy. You just have to put in parallel 3 resistors and add 1 resistor at the top here. Okay, next topic, the flash file system. The C64 has got a directory of files. Maybe I'll just show you. I haven't showed you the keyboard either. Just connect it up. Okay. Oh, something crashed. One moment. Okay. Now I can happily type on my keyboard. And I'll show you the internal directory. Normally, if you just say load on the C64 or CEFI as we say in Germany, you get to load a file from the tape recorder connected to it. But here it is patched kernel, so oops, I have to tell it what file to load. But here we can load from the internal flash directory with this command. Okay. Say list, and that's the files that are in the flash. Now it are not really the files that are in the flash, because this is really a fake directory, as it turns out. But there is a directory in the flash that says which files are there, and each directory entry in this flash directory consists of a file name, the start of the file in flash, that's the start address, and a load target address. What's interesting is that in the directory structure there's not a size for the file. The size for the file while loading it is discovered through the run length encoding that the file has. The run length encoding means like if there are blocks of zeros and ones alternating like 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, it just says something like 0, 1, 2 bytes repeat 50 times or something like that. That's like this kind of encoding that's used in the DTV. And it has also got a terminating byte like 0 when you are finished with decoding everything. And that's how the length of the file is actually determined. Yeah, and that's what I just said. There's an additional file named $, for the directory listing. So when I said load $, it actually loaded the file $. That makes the flash loader simpler for the developers. But that's not so good when we add files to the flash, because they might not show up in the $, directory if we don't patch that also. Okay, how can I transfer data to the DTV? I've got 2 options, either by using a floppy disk or by DTV trans. Come on. Today, please, maybe. There. When you decide to transfer the files via disk, you just use a 1541 floppy drive or a 1581 floppy drive. That's the standard Commodore drive, the first one of those. And you connect it to your PC with an XA 1541 cable or an XM 1541 cable. This one connects to the parallel port, and you can like put files on the floppy, and you could also run it on a normal C64 if you want. Or now you connect the drive to the edge connector on the DTV, and most games work this way. If you just take the disk image, put it on a floppy, and run the game on the DTV, it will work, because the DTV does a real nice job at resembling a C64. When you want to connect the PC and the DTV to the disk drive at the same time, you'd like just use these 2 commands. It makes both devices don't pull the clock line low at all times, blocking the other device off of the bus. So like if you only use the C64 at the one time and the floppy at the other time, then they can both be connected to the same device at the same time. Oops, I think I pressed 2 times. Or whatever. DTV trans is the other option. Right? One moment. You like make a cable yourself. It connects the power port of the PC to the joystick port on the DTV you added. I forgot to tell you in the beginning, a joystick port just only is also 5 wires connecting to the PCB. It's like where the normal joystick is. There are also the pins for the other joystick. That's where the 4 keys in the front are. There you can solder the other 5 wires. The cable consists only of the 2 plugs for the joy port and for the PC power port and of 5 diodes. The diodes, they are only so the parallel port of the PC gets open collector style. That is, it pulls to G and D and can sense the level on the wire. That's so that both devices don't drive against each other electrically. The software is special software on the DTV and PC. There is a basic program available for bootstrapping. So if you haven't got a floppy device, you can like just type in a simple basic program on your keyboard and bootstrap it that way. Yeah, you can transfer data from and to the RAM of the DTV that way. You can also read the DTV's flash. And now lately there was even a patch so you can write directly to the flash using DTV trans. Okay, let's look at the structure of the c64 DTV. We've got 64K address space, memory mapped I/O. I/O registers resemble those of the c64. And the c64 bank switching scheme through the addresses 0 and 1 is also resembled. That's because so it's compatible with all the games and stuff like that. There are now also additional features added. It's got 2 MB of RAM and 2 MB of flash. Now I'll tell you in a moment how it works together with the 64K's address space you only got. The CPU registers are remappable. That's a very interesting feature. Then you also got burst modes for the CPU. It makes it faster. The VIC is improved. The SID is improved, yeah, and somehow also slaughtered. A DMA unit is added and a blitter is added. CPU improvements, you can put it in skip internal cycle mode and you can put it in burst mode. In burst mode, it can actually fetch 8 RAM bytes at the same time from the DRAM that's on the board. And then it can like execute 4 immediate instructions, if that says something to you, at the same 1 megahertz cycle. So it's like really fast if you align your code on the 8-byte or 4-byte boundaries. I'm not sure right now. That's something for you demo coders because I'm not really so interested in writing optimized ASM on it. But yeah. There are new VIC features. You've got 256 colors. It can address the full 2 MB of RAM. That's very interesting. And it can display 320 times 200 pixels at 256 colors at the same time. Now that's really remarkable because when you remember the c64, it could natively only display the full 16 colors if you told it to like always combine 2 pixels that are left and right of each other to 1 pixel. So it had like 2 bits to encode 4 of the colors you could select, and then you could do tricky things like switching the colors between the lines. But yeah, it's like really, it was really complicated to get lots of colors at the same time on the normal c64. So then this unit really makes it easy if you want. The video timing is programmable. It can be programmed to NTSC and PAL, also keeping the same oscillator. Although the PAL and DTV and NTSC units that exist use a different one. The bad line emulation can be disabled. Normal c64 has got bad lines. They happen every 8 lines. That's when the characters are fetched that are going to be displayed in the next 8 lines. The video chip needs more memory bandwidth, and that's why it stops the CPU for a time to have full access to the memory. So you the CPU is really stopped every 8 display lines for about that raster time. on the screen, and yeah, it's like really painful if you code some stuff on it. And this feature actually is only emulated on the DTV, so the games run, and you can turn it off, so you don't have any bad lines anymore. Yeah, and the borders can be disabled, so you can natively display sprites in them. The SID was modified. Yeah, well, the audio filters were removed. That's what I meant with slaughtered. Some sounds don't really sound nice with removed audio filters, but it's okay for most games. But it's not going to be very good if you want to use it as a musician. Some other features were added, but I'm not really a musician, so I don't really understand them. But there's a guide that says what features were added and what were removed. I'll show you in a moment. I'll drink something. I'm getting a little worn out. Okay, this is the memory map and bank switching of the original C64. Like the C64's processor, the 6502 can only address 64 Ks of RAM. Now, how do I solve the problem? Because it has, no wrong, it can only access 64 Ks of memory. And how much memory has the C64 got? It's got 64 Ks of RAM. Now, it still also has got 5 kilobytes of ROM, I think, or 5, no, that's not right. Let me see, 8, 16, no, 18K, right? Any expert in there? 8K? No, let me see, the basic alone is like, it's 8 to C, is that right? ABC. That's 8K, the kernel is 8K, and the I/O is an additional 4K, so 8K, 4K works out to 20K, right? 20K. Okay. There are 20 Ks of ROM, so the C64 uses a bank switching scheme, so you don't have all the RAM all the time, but you can select via these two first memory addresses if you want basic or RAM in this part, if you want I/O or RAM in that part, and if you want kernel or RAM in that part. This region is always RAM, and this one also. This one's really smaller, but yeah, you get the idea. Okay, so now I'll show you what the memory map on the DTV looks like. Now it's copied from the C64 for the most part. It's just that instead of 64 Ks of RAM, you have 4 DTV banks instead. Normally, they're just mapped to the first 64 Ks of RAM in the DTV of this 2 MB RAM, so it just resembles a C64. But you can remap each of those banks individually, and you can map it to ROM, ROM or RAM, right? What was interesting on the last slide was the feature through the first 2 addresses to select the banks is still kept. So it's like 2 bank switching schemes on top of each other. Okay. Now the bank switching registers are actually let me first tell you about these CPU registers, because there are now 15 CPU registers instead of 3. A, X, and Y on the 6502. The new registers, the 15, are mappable to A, X, and Y. Normally they're just mapped 0, 1, 2, but where you can remap them by special opcodes. Like have remap the accumulator, and you have remap X and remap Y. Now the registers of the set, of this 15 register set, 12, 13, 14, and 15, select the bank base addresses for the 4 memory banks I just showed you. So that's how you get that memory. Okay, there's an official programming guide that tells you all the questions that you still have left if you want to code your demo or something. It's called dtvprogramming.pdf. You can find it on the net if you Google it. Okay, I'll now summarize the known limitations on the DTV I ran into. It's like, most importantly, no SID filters. some VIC bugs. I saw that in demos. They just don't look correct. I don't know exactly why. There are no real-time clocks in the CIAs. CIA is a complex interface adapter on the C64. It's not the CIA. I ran into that misfeature when I was fixing one game for the DTV, and it like relied on the RTC as a random number generator, and it didn't work. There didn't appear any opponents, no, not opponents, any enemies, and that was because the random number generator relied on this RTC. And the keyboard metrics can only be read in one direction. Now, the C64 normally has got this wonderful keyboard on it, and it's really only the buttons on a PCB. Every time you press a key, it like connects the two corner points of an X and Y matrix, and this is read by scanning the rows and reading the columns if there is a key press in the column, right? And if I read this row and one of the keys is pressed, I get a key press in the according column. Now, because it's only really switches connected between two I/O ports of the C64 in X and Y way, on the C64 it doesn't matter. You can say, hey, I put signals on that one and read these, or I put signals on these and read that ones. Now, on the DTV, we can connect the PS2 keyboard, and the PS2 keyboard is not a matrix keyboard. So in the ASIC, in the DTV, there is a converter that converts the PS2 scan codes to matrix codes on the simulated, on the resembled CIA ports of the virtual C64. And thus, this logic only works in one way, in that direction that the normal C64 kernel reads the keyboard. Some games read it the other way around, and that's why in some games keys are not working. Okay, I hope you understood that. Maybe I'll explain it in more detail later if you didn't, but okay, let's first go on. Okay, reflashing the flash. If you got an SST flash, there's a hardware fix needed. I'll show you that first. Then there are 3 flavors of flashing software out there, to my knowledge. It's the flash tool from TLR, it's DTV Trans Plus, and it's TULF. TULF is my own creation. I'll tell you about that later. Okay, first the SST flash fix. That's also analyzed and fixed by me. You can find it also on the web. Something's wrong here. Okay, flash chips rely on, okay, first I'll tell you what's broken. The SST flash just didn't respond to our commands when we tried to get it to flash. Normally, to flash a flash chip or to execute another command on it, you just don't write the byte you want to the memory address and it's in there, but there's a magic sequence you must do. It's like to protect the flash from accidental access or something like that, like when booting up, power glitch, flash broken, bootloader broken, oh no, product dead. No one wants that. So you need to do this magic sequence, write AA to AAA, write 55 to 555, write F0 to AAA, and then you can write the byte to the target address. Now, that sequence must be done in the right order, and this is what the write access on a DTV looks like. I sampled this with a logic analyzer. It's not here where the problem happens, where the green line is. That's only the trigger point of my logic analyzer, because I triggered on the condition that you see the write access at. Write access is seen by a flash chip when the negated write enable line and the negated chip select line are 0 at the same time. So here's the valid edge where the normal write access would take place. Now, here is where the problem occurs. Write is still low. I think this has to do with the DRAM timing. The chip select for the flash is just going low on the same edge as this write enable line goes high. Now, with the Atmel flash, this wasn't a problem. It doesn't see this as a write access. But the SST flash sees this as a second write access. So you have one write access, two write accesses. So the magic sequence is broken because every part of the sequence is doubled and the command is not correct anymore. Now, how can one fix it? Now, my idea was I just delay the ship select to the flash a little. It's like about here maybe. And how does one delay something like that? It's on my next slide. Here, using a capacitor. It's like a little hard on the line, but okay, it works. Just connect a capacitor to VCC. You could also use GND, but VCC was was nearer. So I just connected a flash ship enable line to VCC with this capacitor. I actually used 100 picofarads first, and it also worked. And then I experimented with values, and like 47 picofarads was somewhere in the middle. So I just said, hey, that's the official value. Use this, and it will work. Yeah, and it does so far. Didn't hear it failing anywhere. Okay, now we can look at TLR's flash utility. It's good for dumping and writing blocks of memory. You don't need to align them on the flash blocks, and you can just say, hey, I want to write 5 bytes here, or I want to write 1,000 bytes there. It just does it for you. You can flash a new kernel with it very easily. But you can't do any file level access. That is, I told you about this directory that's on the DTV where all the files are in. But you can't just say, hey, delete that file and replace it by that one or something like that. So it's not really so good to add new games to the DTV or something. This is what it looks like. You will have got some options. It can also, that's on the next slide, show you a nice map of the flash. Here the big balls, they are like used sections. The dots are empty sections. It says a section is empty if there are only Fs in it. So it isn't really that reliable if you already played around with the flash and maybe files are already deleted in the directory, but the blocks aren't erased, so it doesn't show up in here. But okay, it's a nice feature. Now, you can patch the kernel of the DTV. Why would I do such a thing? Yeah, to fix some bugs. There is a bug in the load routine. I don't really remember what it does. But more importantly, to add a hook to the start up boot program. So you can use a soft kernel or start a program on boot. It's like what I did on my DTV. It was this DTV boot, what you saw. It's also from TLR. And you can also patch some other features like hardcode the video modes or say, hey, I don't want to press the control key on the keyboard to get in basic mode on startup or something like that. Okay, how? Use TLR's kernel patcher. And then it just writes a kernel file for you or puts it somewhere in memory. And then you can flash it later using the flash utility. Works really nicely. DTV-trans Plus is another way to flash the DTV. It's a mod to DTV-trans. DTV-trans can normally only transfer files to RAM, but with this mod you can also sync the image in the flash on the DTV to a flash image on your PC. Problem is it takes really long. Takes like 8 to 20 minutes because first it downloads the flash from the DTV, compares it to what you've got on the PC, and then rewrites the new sectors. I was going to show you today, but I tried it out yesterday and it took really long, so I canceled it. Okay, and then there's Tolf. That's my utility. It's to do file level access on the flash. It can also patch the DTV's boot up game menu. It can load files from disk or via DTV-trans. It needs a patched DTV-trans version if you do the latter, and you can get it at that URL. I put the slides online later. Now, where do I get games that I can flash to the DTV? They're on this repository. It's from Spaceman Spiff. That's his nickname. These games are patched to run from the flash ROM. You don't need to patch most games when you want to run them from a disk drive and have a keyboard. But it's almost always needed to patch them if you want them to run from flash and you want to use them without a keyboard. So the games in this archive are patched to be runnable without a keyboard and run from flash. They are in a special zip format that is understood by this DTV make file system utility or my12 utility. What's next? Let's check out. Okay, let me first show you my utility before we go on. Okay, there we are again. Like I cheated, I already loaded it to the internal flash using itself. So I can just load it and run it. Okay, it first needs to scan the flash to find all the files that are in there. That's because of the run length encoding I told you about. The file length isn't stored, so it doesn't know where a file ends. It needs to trace the RLE of each individual file on boot up to find out how long it is. That's why it takes a little to scan all the files. So this is like a file browser, okay, you can see it. I plug this into this is the DTV trans cable. I plug it into the joy port of my DTV. Okay. I have to run a command on my notebook. Wait a moment. That's because, hey, how do I end the presentation? Okay. That's because I just booted the notebook and now connected it to the DTV, and normally it blocks the keyboard then because the parallel port is in a state where it like pulls low some lines on the joy port of the DTV and that blocks the keyboard, so I needed to clear it up. Okay, now I can use this keyboard to browse the files that are in the ROM. It shows the files and it shows empty spaces. It's sometimes not really that responsive because I coded it in C. I wasn't in the mood to program all of it in assembler, so just use C. Yeah, well, you can see all the files that are actually on the DTV here. It doesn't use this $ file at all. It just ignores it. Yeah, now let me show you how you can add a game. I go to the DTV trans menu, select the port I want to use to connect the DTV trans cable to. You can connect it to joy port 1, joy port 2, or to the user port. It's also got a user port, but yeah, I don't really need it. Okay, now I start the DTV trans server. I think I just show you a c64 screen. The PC screen might also be interesting, but I'll just tell you what I'm typing. Okay, I go to the directory where I've got the file. Oh no. My keyboard's broken. Can't press some keys, need to copy and paste the URL, okay. Should I type anything in? I press the key, but nothing happens. Let me see, DTV is here. I need to write DTV trans. TV, tab, no, not yet. Ah, there it is. Okay. Okay, I'm typing DTV trans U, that's the option for upload. And now the file I want. This is, in this case, Katakis DTV.zip. That's an archive of the fixed game Katakis. Now, okay, now I press enter. Let's hope that it works. Something happen? Not really, right? I plug this in. Wait a moment, maybe this isn't plugged right. Or this. Okay, something crashed on here. Okay, have to go through it again. Okay, DTV trans, start the server, work, please, maybe. Ah, yeah, now it's uploading Katakis, okay. Then it searches for a free block in the flash and adds it to it. It's not actually flashing it yet, because you remember the DTV has got 2 MBs of RAM also, so I just copy the files to RAM first and I'll flash them afterwards. So first I just see that everything fits and stuff. It already allocates a block for it in the flash, but doesn't flash it yet, okay? Now adds all the files of the game. This is like all the level files. It's okay. Okay, that's it. Now I press escape here, go to Flash, and tell it to write it. Now it's actually writing to the Flash. No, it intelligently finds out which of the blocks of the flash still need erasing, and after that need reflashing of parts of the files that were in there and stuff like that. So you can like just flash anywhere you want and it will work. Okay, that's it. It rescans the directory and now we've got Katakis in it. I forgot to use the feature to patch the DTV menu. Okay, he already added an entry for me up here. This is the files that are in this game menu. But I still have to compile the menu. Okay, go to the flash menu and reflash it again, because now it adds for me, it's shown in red, I'll show you here. It adds a new DTV menu. It deletes the old one and writes a new one. This one's the patched one, but I still have to tell it, hey, write this to flash, please. So go through that procedure again, but it won't take this long this time. Okay, that's it. I can also reset now. It was already rescanning. Okay, so now start it up. And here we got Katakis. This fix isn't actually released yet, but I'll release it in a couple of days or something. Okay, so here we are. Yeah, this is actually nice Chris Hülsbeck music in this game. Yeah, well, okay. Oh, okay, reset this again. Yeah, but you see, I can just add the game to it, and there are like lots of games in the repository already. Maybe some more in the next time. We'll find out. Still, people are fixing games. Okay, I'll return to the slides for a moment. Let me see what I've still got. Don't remember really how much I've got still. Okay, looks like if I'm already almost finished. Okay. I'll go through the rest of the slides a little faster so you can still ask some questions. There is now an emulator for the DTV. I plan to show you, but I'll leave that out now. Just believe me, it can emulate the DTV real nicely. It's called Vice Plus, just download it. You have to give it a flash ROM image from the DTV and it'll work. If you still need a flash ROM image, well, I'm down in the hack center. It supports almost of the DTV's features, almost all of the DTV's features by now. Yeah, great for patching games or developing demos, of course. I always patch my games in it because like you've got a nice monitor, go into it, set a breakpoint, and yeah, it's fun. Wait a moment. I'll just this one here. close OpenOffice. I just restart the OpenOffice presentation because I think then this delay between the slides will go away. Okay. Coding tools, Acme assembler, DASM assemblers, cc64 is a C compiler. TULF is written using it. It's a little slow though. There's an Exomizer cross compressor. You can use it to compress files that are too large to fit the memory image normally. So you take the Vice emulator, make a memory image, compress it using Exomizer, and then you can just unpack it on the DTV and it will run. So that's really nice for fixing games. Okay, there are also some disk drive emulator projects out there. They want to emulate a 1541 drive. The problem is the 1541 drive has normally got an own processor and it's really hard to emulate it, and that's why they don't. They just emulate the protocol. So floppy speeders won't work. Most games use speeders, so most games won't work without a patch. Kind of the same patch to make it workable from Flash, so I don't really see a big reason to use them. Lots of people are using that stuff, but I think because they don't understand the limitations. Yeah, well, there are nice versions of them that can be integrated in the DTV case. There are mainly two projects. These two. On the right-hand side, this is the MMC2E IEC. It uses an Atmel microcontroller. Here comes the SD card. This is the IEC bus. This is the 1541 free. It uses a PIC microcontroller. Okay, we're almost at the end. I'll show you some nice case mods for the DTV. This is TLR's DTV. That's the guy with the flash utility and the video fix. He just put in the old school joystick connectors and put a keyboard connector here and a floppy connector there and a power connector here. This is my own mod, it's this one. I don't like these big connectors on it. That's why I used PS2 connectors for everything and use an adapter to connect other stuff. Like this is my joystick adapter, for example. Yeah, you can also use a plastic box and just put the PCB in there, but I don't think it's that interesting. I like the joystick with the DTV in it somehow. Another nice mod I've also got here, it's from my friend Ansgar. We actually did this together. This is a Webbit keyboard, I think. No, it's not Webbit. It's like some kind of an infrared keyboard from Web PC. We had to build with a microcontroller the PS2 to the Matrix keyboard to PS2 converter to connect it to the DTV. Yeah. This is the nicest mod I found. It actually doesn't use the c64 DTV, it uses the Hammer DTV, but it uses the same chip, so it's actually also a DTV mod, I think. Really got the screen in there, and this is really nice work, this thing. Okay, I want one, where can I buy it? Weltbild, go there and buy one, only $14.99 and they're PAL, as far as I heard. So you want them. Conrad Electronic also still has them, $22.95 the last time I checked. Pearl seems to have only NTSC DTVs, you don't want them, don't buy it. Yeah, sometimes it's hard to tell. The question was, how can I tell which version it is? Sometimes it's hard to tell. Just better ask someone who bought one there, because there are online communities, so you can find out if it's this or that one. Because sometimes they've got the wrong picture in the on the website. You know, it's like this. When you look at this casing, it's the PAL unit. The NTSC unit has got something like a pyramid or something. Okay, some links. That's really only if you download the slides. Okay, that's the end of the presentation. Okay, what time is it? Yeah, I think we still have time for some questions.
Test. Hello. Are there any ideas why they designed the DTV in this way? I mean, they put all the pins needed for a floppy controller and whatever. It's like go and hack it.
Yeah, right. As I already told you, the designers of the unit are really cool people, and they wanted to make it hackable. It is, they did it on purpose.
So further questions?
What is involved in making ordinary C64 games work from the flash embedded in it? What do you need to do? Do you change the memory addresses only, or is it more...
Sorry, I didn't quite make that out.
How do you patch the games to work from the flash? Do you just change the memory addresses, or is there more work involved?
Okay, to patch the games to load from flash, you have to patch the disk drive number from number 8 to number 1, and that'll do the trick mostly. The problem is you've only got load file from disk to memory. You haven't got load byte from disk. Many games use load byte from disk. That won't work. And another thing is many games use floppy speeders, so you better first search a version of the game that uses a kernel loader and patch it to use drive 1 instead of drive 8, and then it'll just work out. Or maybe you'll patch it to use the address that was used before to load the file. I think it was $BA in the 0 page, but I'm not sure if it really was that address, but it's somewhere in the 0 page, the last drive number that was used.
Further questions? Well, if that's not the case, let's thank the speaker again and